Hey, so Paralyzed Math and History, and we are going to be completing the square part 2. So in the last video, we have been trying to complete the square by understanding what the C value was. But what happens if we already have that C value? How do we do that again? How do we try and complete the square? Well, in this case scenario, you know how we had two parts where you have to find the C and then try and factor it? Well, we don't have to do the first step because we already have the C. Instead, we're going to try and find two factors which are represented into X to try and see what our new factors are, or our binomials. Here's an example. We'll have to subtract this side by 105 and subtract this side by 105. Now our new equation is x squared minus 22. Wait, do you remember in the first part of the video where you said that we don't have to find the C? Well, we have to find the C in this scenario equals negative 105 empty space. The reason why we do empty spaces is even though we have to find the C value, it will help us toward getting to our goal, finding two x's that can be inserted to make this equation true. Okay, so we have x squared minus 22x blank space equals negative 105 blank space. So, we have to use the formula from the last video, b divided by 2 squared. So in this case scenario, negative 22 represents our b value. So negative 22, divide that by 2 squared. And that means it is negative 11 squared. We're going to star that because we can use that for finding one of the factors, x minus 11 squared. That is only this side of the problem. Now we have to find the other side of the problem. In order to do that, we have to square negative 11. So negative 11 times negative 11 is 121. And on this side we have 121. We have to combine the two, and now we have positive 16 when you combine the like terms. So now we have x minus 11 parentheses squared equals 16. We are so close to getting to our answer. When we do that, since we want two values for x, we are going to have to use the square roots. So we're going to square root the 16 and square root the x minus 11 parentheses squared. So technically, you have to square root the square. When that happens, the square root and the square cancel each other out. It's funny because if you try to find the square root of 4 squared, they'll cancel out and the answer will be 4. So now we have x minus 11 equals square root of 16, 4. We have positive and negative 4, because positive 4 times positive 4 is 16. And negative 4 times negative 4 is also 16. We are so close. To get the x alone, we add by 11, add this side by 11, and here we go. X equals 11, add or subtract that by 4. We're going to have two values. So 11 plus 4 is x equals 15. Or 11 minus 4 is x equals 11. Or x equals 7, I mean. So that are the two numbers inserted in for x, these two x's, that could make this equation true. So the reason why we try to complete the square in the first place is it's a new kind of method just in case when you factor or if you square root, it will not work. Sometimes factoring doesn't work, and some other times square rooting the problem doesn't work.
Yeah, just keep heading up those stairs and you'll hit that engine room in no time. I guess this rocket has an internal engine room. It probably, manages the electronics or something. I don't know. I'm not a rocket doctor. Anyways, do your thing, buddy. Seems like the engine is ready sooner than we thought it'd be. Let's get out of here.
This doesn't seem right.
Here's an example. Here is when we factor using the diamond problem. Let's say you have 1 up here and 6 on the bottom. What two numbers can multiply to 1 and add up to 6? This is an error. It's actually not going to work. This is actually going to be a fail. Because no number but itself multiplies to 1. But how can you also add up to 6 at the same time? When you square a problem, you have x squared is going to equal -3. And when that happens, you can't do that because when you square root them, you get x equals square root of -3. There's no real solution. So that's why if these two don't work, then completing the square is going to work. So these two other methods are also fails. The answer we got in the previous problem, since we have integers for x, that allows us to understand that we could have used the diamond problem and we could have factored it out. Let's see one more example, but this time we're going to see an example where x is not equal to the number 1, which means x could have any other number in front of it as a coefficient instead of 1. Okay, so we have 5x squared minus 8x equals 4. The only difference in completing this problem is since we have a 5 as a coefficient in front of the x squared, or the formula ax squared for your quadratic standard form, we have to move this 4 to the other side by -4. So now we have 5x squared minus 8x minus 4 equals 0. When you do your first two steps, always make sure that when you divide, have everything in on the left side of the equal sign. Then when you do that, you can return it back to its normal. So divide everything by 5, we will get fractions, unfortunately. X squared minus 8 over 5x. And we have -4 over 5 equals 0. So since we got x squared alone, we can proceed as normal. Add this side by 4 over 5. Add this side by 4 over 5. And that tells us that when we move that back to the right side, we literally wrote it in a different way, but it has the same value. X squared minus 8x over 5, well, 8 over 5x, missing number equals 4 over 5, missing number. What two numbers can be put in here and they're factored? Instead of using b divided by 2 squared, we could also use 1/2 of b squared, normally used for b's that cannot be divided by 2, or they'll become fractions. So it's another way of saying it, but helping us get to the right answer. So negative 8 over 5x, or just negative 8 over 5, multiplied by 1 over 2 is going to be 8 over 10, or simplified 4 over 5. Always simplify your answers. So 4 over 5 squared, that's going to bring us to 16 over 25. It's going to be on top of here. Our factor is going to be x plus 4 over 5 squared. That is the left side of the equation. Now we have to find the right side. Okay, so we have to add the two. 4 over 5 and 16 over 25. We want to find common denominators. So since these two are a multiple of 25, times 1 times 1, 16 over 25, we change the top one, times 5 times 5, 20 over 25. Add the two, and we get 36 over 25. So since that is these two combined, we get to write it in a new way. X plus 4 over 5 squared is going to equal positive negative 36 over 25. When we square root them as normal to cancel out the squares, we're going to have x plus 4 over 5 equals 6 over 5, add or subtract. Here is the last step. Now we have to subtract that by this and subtract that by that. So x is going to equal our final answer, negative 4 over 5. Add that or subtract that by 6 over 5. You will get x equals 10 over 5, which can be simplified into x equals 2, or x is going to equal negative 2 over 5. So these two x's can make that equation right up here true. So this method, completing the square, can actually work for any kind of problem you want. And if you pair it up with any kind of situation or problem, unlike the last two that we discovered, it is always going to work. I hope this video has helped you. Thank you for watching Top Life's Math Industry. Like and subscribe. And to end the video, let's see Henry Stickmin complete the mission!
Welcome to Stickmin Space Resort. Built out of a former Toppat base, it's been refitted for your luxury enjoyment. We Toppats aboard have reformed and now work as crew members. The Toppats that remained on Earth were arrested, as you know. The resort is run by the man himself, Henry Stickmin. You may wonder, why did he steal a criminal clan's rocket and decide to turn it into a resort? We may never know, but hey, you wouldn't be here if that didn't happen. Enjoy your stay.